Have you ever wondered if it's possible to travel across the universe in mere seconds? What an exhilarating concept. Let's take a moment to imagine the vast expanse of the cosmos, teeming with galaxies, stars, and planets. With our current technology, traversing even the smallest fraction of this vastness would take lifetimes. The nearest star to us, Proxima Centauri, is about 4.2 light-years away. Even traveling at the speed of light, it would take us over 4 years to reach it. But what if there was a way to circumvent these astronomical distances? A theoretical shortcut, if you will. This is where the concept of wormholes comes into play. These are essentially tunnels, or bridges, through space-time that could theoretically allow us to travel from one point in the universe to another in no time at all. The question now is, can we actually travel through these wormholes? Imagine if a shortcut through space-time actually existed. Wormholes, a term popularized by science fiction, are a legitimate scientific concept. These fascinating phenomena are not just the stuff of Star Trek or Interstellar, but reside within the realm of scientific possibility, nestled within the intricate fabric of Einstein's general theory of relativity. So what exactly are wormholes? Picture the universe as a vast cosmic sheet, stretched taut. This sheet is space-time, the four-dimensional stage on which all matter and energy play out their roles. Now, imagine that you could fold this sheet in such a way that two distant points touch. A wormhole is like a tunnel connecting these 2 points, a hidden bridge across space-time. According to Einstein's theory, the gravitational pull of massive objects warps the fabric of space-time around them. This is what we perceive as gravity. Now, if the fabric of space-time can be bent by mass and energy, it's plausible that it could be twisted and folded to create a wormhole. Theoretically, wormholes could connect two distant points in the universe, allowing us to traverse astronomical distances in a fraction of the time that conventional travel would require. Imagine being able to hop from one galaxy to another as easily as crossing the street. That's the magic of wormholes. But it's not all smooth sailing. To keep a wormhole open, we'd need a form of negative energy or exotic matter, something that's yet to be discovered. Without it, wormholes would collapse too quickly for anything to pass through. Despite these challenges, the tantalizing potential of wormholes keeps scientists exploring their mysteries. They provide a fascinating lens through which we can view the universe and its many wonders. So wormholes could potentially be the universe's version of a cosmic shortcut. They're a testament to the boundless possibilities that lie within the realm of scientific exploration, reminding us that the universe is not only stranger than we imagine, but stranger than we can imagine. So we have these theoretical shortcuts, but can we use them to travel? This is where things get a bit tricky. The idea of wormhole travel is indeed captivating, like a sci-fi lover's dream come true. But let's take a step back and examine the reality of it. Our current understanding of physics suggests that wormholes, if they exist, are inherently unstable. They're like cosmic quicksand, collapsing in the blink of an eye. That's not exactly what you want when you're planning a trip to another galaxy, is it? To keep a wormhole open long enough for any meaningful travel, we would need something known as exotic matter. Exotic matter isn't your typical stuff. It's not something you'd find in your backyard or in the deepest trenches of the ocean. It's a form of matter that is yet to be discovered, and it's supposed to have negative energy density and large negative pressure. In layman's terms, it's the kind of stuff that could keep a wormhole's throat open, preventing it from collapsing and potentially crushing anything that attempts to pass through. But let's say we do find this exotic matter and we manage to stabilize a wormhole. What then? Well, there's the small matter of the potential dangers involved. What if the wormhole leads to a region of space that's inhospitable to life as we know it? What if it leads to a time before the Earth was formed, or far in the future where the Earth no longer exists? So while the idea of hopping into a wormhole and popping out on the other side of the universe is alluring, it's riddled with challenges. From the instability of wormholes to the need for exotic matter to the potential dangers involved, the reality of wormhole travel is a far cry from the romanticized version we see in science fiction. While it's a fascinating concept, wormhole travel currently remains within the realm of theory. But who knows? Maybe one day, we'll crack the code and rewrite the rules of space travel. After all, the future is a vast, unexplored frontier, and we're just at the beginning of our journey. The question remains, will we ever be able to travel through wormholes? As we traverse the expanse of the cosmos, we are often confronted with questions that challenge our understanding of the universe. The concept of wormholes, for instance, is one such enigma that has intrigued scientists for decades. Research is still ongoing to unravel the mysteries of these space-time tunnels. Some scientists speculate that wormholes could potentially serve as shortcuts across the vast distances of space. This could revolutionize our understanding of space travel, making journeys to distant galaxies a reality rather than a sci-fi fantasy. But it's not all about getting from point A to point B. The study of wormholes could also shed light on the fundamental laws of physics, broadening our comprehension of the universe. However, it's essential to remember that science is a field of constant discovery. Today's impossibilities could be tomorrow's breakthroughs. After all, it was only a century ago when the idea of landing on the moon was considered a mere pipe dream. So while the concept of traveling through wormholes might seem far-fetched, we must keep our minds open to the possibilities. Science, after all, is about pushing the boundaries of the known to uncover the secrets of the unknown. Who knows what the future holds? Perhaps one day we might just find ourselves stepping through a wormhole. So, what have we learned today about wormholes and the possibility of traveling through them? We've delved into the fascinating world of wormholes, those theoretical tunnels in space-time. We've grappled with the challenges of this form of travel, the immense energy requirements and the destabilizing nature of wormholes. We've also peered into the future, where research continues to unfold the universe's enigmatic wonders. While wormhole travel remains a theory, the universe is full of mysteries waiting to be unraveled. Stay curious and keep exploring.